Okay, Xian, Xian is here, and I would like you to present to you our next keynote speaker. Xian is a Deputy Director of Cloud Computing Institute at Panag Laboratory. He will deliver a keynote. His keynote is SilkRoad Multilingual Communication Platform, and he will give us insight and tips and bits of multilingual communication platform. Thank you. The floor is yours.
Thank you for the introduction. I'm very glad to stand here because this is my first time to Siberia. And firstly, I will say my thanks to the conference community to invite me here to give the keynote to you. And also, I just finished a Sino-Serbia session on the 7th floor, and then I came back. Okay, so before introducing the SilkRoad communication platform, I would like to briefly introduce what is the Panag Laboratory. So this is where I come from. Panag Laboratory is a national level research institution in China, and the primary research focus of Panag Laboratory include network communication and artificial intelligence. So the Institute of Cloud Computing or something else, we mainly focus on artificial intelligence, and we try to build large language models or other artificial intelligence models on top of a large computing cluster. So that was what we have done in the past several years. And this one, SilkRoad, on the platform, we also developed several applications, including machine learning tools, machine translation, automatic speech recognition, text-to-speech applications, and so on. I will introduce them. So I'll start from the background of our research, mainly on the motivation of conducting this kind of a platform, and then how we have done and what we have done in the past 2 years of developing, and then the NLP techniques behind, how we support the big platform, and how we run our collaborations with other companies or institutions. And finally, I will say something about a frontier exploration called computing network. So that was one our Panag Laboratory is now primarily focusing on. And finally, the summarization. Okay, so the background is quite simple. You know, now many people in the world speak different languages, but for some of them, they are on the brink of extinction. That means some languages are dying because fewer and fewer speakers speak those languages. We call them under-resourced or low-resource languages. So similarly, the cultural heritages are also facing the similar situation. And some world heritage sites are threatened by many factors, such as wars or natural decays. So these remind us to be aware of how to preserve them and how to protect them. This is, I think, in an emergent manner. Fortunately, we can use some digital techniques such as digital twins or artificial intelligence models to help us to do the protection. Where's the cursor? Okay, so the figure in the right bottom one comes from a recently very popular game called Black Maze Wukong. Wukong is a famous character in China, and it's also called the Monkey King. You know it? Yeah, they have they have the weapons to fight against the monsters. So in this game, it's a computing game, many historical sites, including temples and wall paintings, and also something like the sculptures were reproduced in this game. So when players are playing the game on the computer or on the Switch or on a cell phone, they can read the story using the scripts and also enjoy what the history was like in the past. So I think this is kind of very interesting and a very very good ways to remind us we have a very good history. We have very beautiful, have wonderful historical heritages, and we need to remind us to do the protection. We need to be aware of this. So that is the simple motivation of doing so for us. And I'll talk about more about the multilingual language model and the machine translation things in this talk. As I just mentioned, many languages are on the brink of extinction. So some companies like Google and also some companies in China, like Baidu, have developed machine translators. Google may be one of the most famous one. We can translate the Serbian language to Chinese language in a very short time. But with the development of artificial intelligence currently, large language models has become a very hot topic in the recent 2 or 3 years, starting from the invention of ChatGPT and the following ones, open source ones like Llama and BloomZ. So I think with the help of large language models, the machine translation between 2 languages become more flexible. It's not just like you input one sentence and the machine translators output one sentence. Using language models, you can negotiate, you can debate, you can discuss with the model as agents to achieve a much more better performance, and you can get more results from the language model itself. So I think using the language model, the large language model techniques, we can have more flexible ways to help us to let the low resource languages be more. I think we can get better results. We can get better performance. We can get better products on top of the large language model. There have been many open source large language models, and also such as Llama and BloomZ, they also provide the multilingual support. So based on the developing experience, for example, we have read several papers published by them. We developed our own multilingual language model. However, there are still very critical problems of developing either multilingual language models or machine translators. Because, if you are dealing with the text understanding for English or Chinese or Russian, this kind of larger language or high resource languages, you will get much better results than you are dealing with low resource or under resource languages. I think maybe Serbian languages is still belongs to the low resource ones. You don't have enough data, but the 3 main factors of artificial intelligence is computing power, model, and data, in which the data is the primary, it's the most important one. So without enough data, even a multilingual language model cannot perform well on many downstream tasks. So we have concluded that low resource, complex scenarios, and the difficult modeling are the 3 main challenges that we face today to developing a multilingual language model. So although somebody has says we need to do something that no language left behind. We still have a very long way to go. Okay, so this chart shows a brief architecture of the SilkRoad, the multilingual communication platform. I don't know if you know the word Silk Road. Silk Road is part of the Belt and the Road Initiative proposed by President Xi Jinping of China to facilitate the communication along many countries. So Silk Road is one that along the continent, and the other one is along the seaside. So the initial goal or initial plan of launching such kind of a platform is to incorporate many collaborators from different professionals and from different areas. For example, we can have computer scientists to develop neural language models. We can also have linguistics to help us to check the quality of data. We also can have psychologists and have other kind of contributors who have data or computational resource or storage resources. So it's kind of a collaboration and a collection of different resources. So from this chart, we can see we have several levels of layers. On the bottom, we Panag Laboratory can offer some computational resources. And on top of it, we developed several language models, and we also deployed several open source ones, such as Llama, and we also deployed the interface of Gemini and the GPTs on top of it. And on top of the language model, I mean the foundation model layer, we also developed several, we can see the vertical tasks, including machine translation, text understanding, automatic speech recognition, and text-to-speech applications. So on the right side, you can see we also have our linguist experts and data scientists. So in addition to what I have just mentioned before, we also have some other motivations of building this kind of a platform. We would like our platform can help us to trace the origin and diffusion of our humans' languages and cultures. We would like to this kind of communication platform and our advanced AI techniques can help us to know about the diffusion of cultures, how the culture diffuse from one place to the other. And also, many like models such as ChatGPT or Llama, they face the problem of generating bad content. For example, very sensitive or political issues they might be involved in. We call this hallucinations, you know that. So I think with the addition of our linguistics or language experts or some knowledge from different perspectives, we can help the models to improve the output quality. And also, you know that I know yesterday you have a very good event about neuroscience. So some researchers have attempted to explore whether large language models can help us understand how we learn a language, especially for the bilingual speakers. We can monitor using some facilities how the brain areas are activated, and then use the large language model to generate what you think. So we also hope our platform can help to do this. Okay, this is a deeper architecture of our platform. You can see there are several components like the online service component, the model evaluation, the model training component, and the computing facilities, and also the user side. So for us computer scientists, we can upload our model and use the data provided by the platform to improve our model performance. And we can use the computing facilities provided by us to train the model, to further pre-training or to fine-tune the model, and then test the model's evaluation, and also deploy the model as some kind of a service, and finally get your products. End users can enjoy the services provided by us, and the contributors, like the data owners, can contribute their data. And for exchange, we can open source the language models developed by us. So this slide shows some demos or some screenshots we developed based on the multilingual communication platform. The left one is a screenshot of Bright. It's a sub-platform developed on the SilkRoad. It's called Belt and Road Intelligent High Precision Translation Platform. On this platform, we ask the users to evaluate their model's performance first, and if they have the top ranked on our leaderboard, we will help them to deploy the models to the output service and provide some application services such as machine translation, ASR, TTS, and also on the right, a digital human. Yeah, the digital human can automatically translate the text from one language to the other language in a simultaneous manner, such as just like the simultaneous interpretation, and then with some further processing. Yeah, no sound, but you can see. Okay, so this is the Vietnam language. And these are some demos of machine translation and ASR and the TTS. This is a demo of automatic speech recognition for the Russian language. I'm not an expert of Russian. Maybe we still have some errors, so we welcome collaborators from the Russian institutions and universities. Could you help me to play the demos of TTS on the right bottom?
实验室是中央批准成立的突破型、引领型、平台型一体化的网络通信领域新型科研机构，主要从事该领域战略性、前瞻性、基础性重大科学问题和关键核心技术。
Simultaneous interpretation is used for such kind of a conference. If you don't know Chinese, I can say some Chinese, and you can see the English or see the Serbian language on the screen. Yeah, we have developed the applications for several languages, because when you would like to get a very good product, you need to collect a lot of data, but we can collect something from YouTube or the open source websites for English and the Chinese, because we know something about the languages. But for other ones, like Arabic, like Russian, like Serbian, we know nothing about it. And we don't know how to control the quality of data from these websites. So in other words, we still need collaborations. This one shows a demo of interactive machine translation. So what is an interactive machine translation? That is a tool developed for professional translators. For example, you are a translator and you are ready to translate a book from the Serbian language to English. You may need to use this tool. And when you are doing the translation process, and this tool can provide you the candidate recommendations and also dictionary looking up functions. So you can look up how to translate the word from your dictionaries or from your database, how they used to translate them. This one was a previous collaboration with the Serbian Institute of Artificial Intelligence, Professor Kulibrik's group. We did this with the help of a company called Huawei in China, and we developed a Serbian language-centered multilingual language model together with the machine translation engines from Serbian to over 50 languages. So I'll pay more attention to introduce the NLP techniques behind this platform. The first step would be to building the multilingual extension from a monolingual LLM. As you know, for most open source language models, such as those ones published by Meta, they primarily focus on the English language. And I know in China, we also developed several ones focusing mainly on Chinese. And if you would like to build a multilingual language model, you need to extend more languages on top of it. So generally, this process contains two steps. The first one is to build a monolingual one. And the second process is to add more monolingual and bilingual text to the monolingual model and to further pre-train the model. So in our experiments, we use a Chinese language model developed by ourselves and add over 50 types of other languages. Now the model is called Pengcheng Mind. It now has supported the understanding of over 50 types of languages, and we will release the model by the end of this year to facilitate the research use. And also, there is the Serbian language. And the second one, and also a very important one during our training, is how to guarantee that different languages can learn in similar paces. Because, if the data embellishment problem exists, it's possible or it's very likely to lead to the phenomenon low-resource languages are overfitting, but high-resource languages are still underfitting. So that was a very big problem when we are doing experiments. We need to adjust the distribution of the training data, but it's still hard to control the quality of the data or the domain of the data. I don't know where they come from. We can use some classifiers to try our best to make the distribution of domains and distribution of languages even than before, but we don't know. We don't know if it is the routine way or if it is the best way to do so. So we proposed a method to alleviate this problem. This paper was published on empirical method of natural language processing last year, EMLP, called Unifying the Convergence in Multilingual Neural Machine Translation. The idea was quite simple. We use more computational resources the memory, to preserve, to kept some checkpoints for each language. For example, if you are training a language model with 10 types of languages, you will have 10 external checkpoint keepers. And for each keeper, you will keep the best performance model so far. And then during training, you use these best checkpoints to guide the training of the downstream models. So basically, you can imagine when we try to train a model with different languages, and the serving language has already reached the optimal, so we keep it somewhere else. And if the English language need more training steps, we let it continues to train. This kind of a simple idea. This model is called language-specific self-distillation. We use the knowledge distillation strategy to let multiple teachers to teach the student to learn the multi languages. And of course, we have obtained some better results than the state-of-the-art methods, and then they can be published. Another problem is how to let a large language model find out the machine translation errors and correct them by itself. This is different from the previous one. The previous one is mainly to solve the problems during the pre-training, and this one is in the inference phase. When you are doing prompt engineering during inference time, you just input to the model some prompts or instructions, and the model can output you your result. So this is based on the reasoning ability or the so-called reflection ability of the current large language models. So we can consider two large language models as different agents. For example, one is the Serbian agents, one is the Chinese agents. If you would like to do a translation, do a machine translation between the Serbian language and the Chinese language, you just design some instructions and let the two agents discuss and debate by themselves. This can also be done by a multilingual language model. So you can use only one model to achieve this goal. So these charts show a general step. Because, with the help of large language models, the paradigm of machine translation has been changed. You don't need to only input and output, as I just mentioned. You can add some external or internal knowledge to the language model as prompts or as instructions, together with your input to the language model, and let the model to think step by step, and to think more, to collect more information to facilitate the machine translation process. And our improvement or our innovation on this is based on the fourth one. When you have the source input, the text from the source language, for example, Serbian, and firstly, you input this text to the multilingual language model and let the model generate a draft output. And then you will design some strategies, some prompt, and input them to the large language model, and generate some candidate outputs further to improve the performance, to improve the quality of the draft. So this forms a loop. We call it iterative refining translation. During this process, we need to design some proper or reasonable supervised signals Otherwise, the model will go, I don't know, go somewhere else. So if we don't have a correct direction, we cannot get very good performance. So the name of the paper is Dual Reflect. We just use one language model to do the loop, to do the iterative refining things. So this method contains 5 steps. The first one is to generate a draft translation from the input source language, and we let the model to do a back translation. For example, when you are doing the translation from Serbian to Chinese, you first generate a draft translation of Chinese, and you back translate the Chinese to the Serbian language. And then you input some instructions to the model to evaluate how similar the 2 sentences, I mean the draft sentence, sorry, not the draft, the back translated sentence and the source sentence, how similar are them from many perspectives. For example, do they convey the same meaning? Do they express in similar styles, and including some subtle details? So after experiments, we found that it is a really helpful strategy, because we can control the iteration times. For example, you can let the large language models to refine 2 or 3 turns to get your satisfied result. We can also set a threshold for this. Yeah, this paper was published on ACL, and if you are interested in it, you can download it. Okay, then I'll introduce some frontier exploration other than the traditional ones. It's called computing network. So what is the motivation of conducting such kind of research? You know, when you are training a large language model, for example, GPT-3, the parameter scale is very large, like 175 billion parameters. Sometimes you don't have enough computational resources within one computer centers. So if you face this kind of situation, what will you do? Wait until the occupied resource to be released? I don't know how long we'll wait. Or you can use the pieces of computational resources from different centers. For example, from one cluster is from Novi Sad, and one cluster is from Belgrade. Can you combine the resources from the 2 computer centers to train a language model? So computing network is a kind of a facility. I give the definition of computing network here. A computing network refers to a collection of computational or computing resources, such as servers and data centers, connected through a network. The network can be either a high band network with just one hop between 2 clusters, or the SNAT existing ones. So we hope that we can try to do some preliminary experiments to see whether we can combine the resources and reach the goal of 1 + 1, maybe less than 2, but the upper bound is 2. There are some critical challenges of doing so. One is the computing challenge. We don't have limited computational resources for a single center, and the other is network challenge. We don't have enough communication resources. For example, we don't have enough network band to transfer several gigabytes of data at one time, so we need to wait the data to be transferred. It's different from the IB network or the Rocket network within one computing center. And we have tried several preliminary methods, the yellow ones. So this is a very simple step, I think. So our solution is try to reduce the combination overhead and the times. So I think through this kind of attempting, we can increase the input-output ratio of combining two clusters compared with computing using one cluster. So we have proposed two strategies. One is to optimize the collaboration strategy. So that was proposed by several of us. And why we introduced this? Because we think currently, with the help of large language models, sometimes we don't need to transfer all the parameters during training, like data prioritization, or use something like the federated learning. We can use the instructions or prompts or some other kind of paradigms to do the model collaboration. And second one is compress the communication volume. That is easy to understand. If we don't need to transfer gigabytes of data and only kilobytes, that will be much easier to train the model. So this paper was published on DSC. It's a Design Automation Conference. It's a conference on the control area. We split a model, that is a transformer model, into two parts. One part is in Novi Sad, one part is in Belgrade. And we use a model parallelization strategy to train the model. The key challenge during the training is the communication volume between two clusters. We need to minimize the communication volume. So we designed a matrix decomposition method that use kind of a method like SVD to decompose the, this is a transformer block. So finally, we can get a very efficient communication by compressing the communication volume 96 times. This one was a collaboration between Panag Laboratory and another IT company named Baidu in China. We have built an experiment platform between two cities in China. One is called Wuhan, one is called Shenzhen. The two centers are located remotely with 1,000 kilometers apart. We have built two scenarios. One is for the pre-training and one is for the fine-tuning. During pre-training, we designed a model that only need to transfer some instructions or some bytes. That is to use the knowledge distillation techniques. And during fine-tuning, we use a structure called ABNet. That means if you are doing machine translation, you can place one transformer net on Novi Sad and the other transformer side on Belgrade, and then compress the communication volume between them. This one is a simple learning approach. I think you know in symbol learning. Currently, we already have dozens of open source language models, and maybe their distributions or their advantages are different. For example, one is good at English, and one is good at Chinese, and the other is good at Serbian language. How to utilize the advantages from these models? So we designed this kind of mechanism. We can assign some tasks to the different models, and after processing the input sentences, they can output their population distributions. This kind of a matrix is much smaller than the total parameters that to be transferred during pre-training of the traditional routines. So we think these kind of mechanisms or using instructions or prompts can further facilitate the communication between different clusters or computing centers. So this paper was published on NIPS this year. Okay. I don't know if I have introduced clearly, but I think there are 4 key points I introduced today. The first one is our motivation. We would like to launch a platform or a plan to further help us to preserve or protect the languages and the cultures around the world. Because, you know, especially the language, we don't have, if we don't have enough data, enough high quality data, we will not be able to train a very good model, and the digitalization process might be hindered. And the second point is large language models. So we have developed a multilingual language model, and we also think with the release of this kind of multilingual models, we developers, either a big developer or smaller developer, you can use your own computational resources to further train or fine-tune your model to facilitate your own scenarios or your own applications and your own languages. The third one is the international communication platform. We would like our platform can support experts from different domains, not only computer scientists. Also, we welcome the collaboration from first other languages, other countries, and also some people like linguists. And the fourth key point is the AI and the big data technologies. Currently, I think the model architectures are getting converging. Most of us use the transformer to do the experiments, to train the model, to fine-tune the model. But in specific scenarios, we also need to design certain components. For instance, if you are trying to do the PEFT, to the parameter efficient fine-tuning, you need to use the LoRa component. Further, maybe next year we'll plan to initiate research named Human Knowledge Dissemination and Cultural Heritage Protection. We think this might be helpful for the protection of cultures and languages. And here I also welcome the collaborations from different countries and different language speakers. Okay, thank you.
Okay, thank you, Xiang, for your experience.